That is the chemical part of the atom. Right? To understand atom, let's first quickly try to understand electron, proton, and neutron. Electron is a negatively charged species. Yes, it's a negatively charged subatomic particle. The proton is
A positively
positively charged. Yes, the neutron is yes,
negative, neutral.
but it's neutral. Okay, it's neutral. Now, the one electron and one proton. So one proton has positive charge, one electron has negative charge. Is there any relationship between the charges of electron and proton, one electron and one proton? Yes. The charge of one electron and one proton are opposite but equal. But equal. You understand this?
Yeah.
Yeah, good. Now coming on to the next point. In an atom, where are these subatomic particles situated? So,
Uh,
so the protons and the neutrons, they are in the nucleus. Yes,
yeah.
they are in the nucleus. The nucleus has protons and neutrons. And can you tell me, because of this, what will be the charge of the nucleus?
Nucleus minus negative.
Positively charged. Because see, it has neutrons, which are already neutral, and then it has protons, which are positively charged. So the nucleus becomes positively charged because of the presence of the protons in it. Clear?
Yeah.
Yeah. Now the nucleus is at the center of the atom. It's at the center of the
Center.
atom. Right? Now, where are the electrons in the atom?
Uh, Electrons, like they're in the
Around the
shell.
electronic is very good. Shells or the orbits. Right? Shells or the orbits. Now these shells or the orbits revolve around the or are around the nucleus of the atom. Yes.
Yes.
Fine. Now, yes. The properties. See, very important point. The next 2 points that I'm going to say. In case of an atom, let's say we have one proton and one neutron. Yes. That they will be in the nucleus. Even if I have 100 protons and even if I have 100 neutrons, all of them will be in the same nucleus. Example, one nucleus has to adjust any number of neutrons and protons. Do you get it? There's one nucleus which has to adjust all the and any numbers of the protons and neutrons. Electrons are present where?
The
On the
elect electric shell.
electronic shells. Okay, simply shells or orbits. Fine. Now, the case of shells is that each shell has a maximum capacity of electrons that it can have, unlike the nucleus. In case of nucleus, any number of proton and neutron in the nucleus itself. But
Yeah.
in case of the shells, every shell has a maximum number of electrons that it can have.
Yeah.
Therefore, we get something called as the electronic configuration for every atom. What do we mean by electronic configuration? The arrangement
Like
of electrons on the shells of the atom. The arrangement of electrons on the shells of the atom. Is it clear?
clear map.
Now, now, can you tell me how do I decide how many electrons do I have?
Uh,
How will I get to know that?
the atomic number.
Very good. So, an atom has got two parameters, very important. The atomic number. What does it tell you? It is represented by capital Z. Yes. What does it tell you, actually? It tells you the number of protons. Okay. It tells you the
Yeah.
number of protons. And the second is the mass number. Do you know what is mass number? Represented by capital A. It tells you the
Yeah.
number of nucleons. Right? Now let's try to understand these. The number of neutrons, the number of protons, sorry, the number of protons is also equal to the number of electrons. Why? See, we learned just now that the charge on one electron and the charge on one proton is equal but opposite. Is equal but opposite. Therefore, an atom is actually neutral overall. It might have some positive charges in the form of protons. It might have some negative charges in the form of electrons. But overall, it has to be neutral. And how will the atom be neutral? It should have equal number of protons and equal number of electrons. Do you get it? Example, let's say the charge on one proton, just the example, charge on one proton is plus 1x, okay? Charge on one electron is minus 1x, okay? So let's say if I have 10 protons, then the charge because of the 10 protons will be plus 10x,
Yeah.
and there should be a charge of minus 10x to actually neutralize this plus 10x. And for that, I should have 10 electrons. Do you get this, Bachchan?
Yeah.
Yeah. So therefore, the atomic number, which is Z, tells me the number of protons and also tells me the number of
Electrons.
electrons. Very good. Now, how do I get to know the number of neutrons? See, A, which is the mass number, okay, it tells me the number of nucleons. What do we mean by nucleons?
Uh, uh, like in the nucleus.
Yeah. So the species which are present in the nucleus are referred to as the nucleons. And can you tell me what are the species which are present in the nucleus? It is just the neutrons plus protons together. Yes.
Yeah.
So A tells me nothing but neutrons and protons together. If I have Z, which is if I have P, I can calculate number of neutrons. How do I do that? Let's say I have Z and I have A. How do I calculate N? So I can subtract Z from A. I will get to know N. Yes or no, Bachchan?
Yes.
Yeah, very good. Coming on to the next point. Yes. We just now understood that whatever number of nucleons we have, they will be present in the nucleus. So the nucleons, the species present in the nucleus, they do not have to move from one place to another. They will be adjusted in the same one nucleus. The problem
Yeah.
comes when we talk about the electrons. Electrons, they have to change the shells depending on the maximum capacity of the shell, correct?
Yeah.
Right? So let's talk about electrons. How do I get to know the number of electrons? That is through the atomic number of the atom, right? And mind it, the atomic number of the atom is the unique card for that atom. If you are a different atom, if I am a different atom, that is because we have different atomic numbers. If you and I have same atomic number, that means we are similar kind of atoms. Do you get it?
Yes.
Yeah. So electrons are on the electronic shells. That gives us the electronic configuration. Electronic configuration. See, the maximum number of electrons on the first shell bache can be 2. Yes. On the second shell, it can be 8. On the second shell, it can be 18. Yes.
Yeah.
So that accordingly, we will have the electronic configuration of the atom. Very good. Now, what is the problem? Till now, yes.
Won't it be 2, 8, 8, and 8? Like 8 continuously?
Beta, can you be a bit louder?
Like, won't it be like 2, 8, and then again 8 on like M shell and N shell? L
Okay.
shell?
Okay. So this is K, this is L. You're talking about M and N, right?
Yeah.
What happens, bache? Actually, it is 18 in the third shell.
Yeah.
Actually, it is 18 in the third shell. But at your level, what do we do is that we take 8 and like that. 8, 8, 8. Okay.
Okay.
So that is the reason. At your level, we can go with 8. Okay. We can go with 8, but actually it is 18 because it has many different subshells that totally gives the number as 18. Clear?
Okay.
Fine. Now, so till now, we have tried to understand the components of the atom and the structure of the atom and how are they actually present in the atom. Now, how do I get to know about the chemical reactivity from this part? See, we understood the chemical composition. Yes, we understood the chemical composition. Now, let's say you are an element, I am an element. So you will have your atom, I will have my atom. Your atom will have a different atomic number, my atom will have a different atomic number. So if we have different atomic numbers, clearly we will have different number of electrons and your electronic configuration will be different and mine electronic configuration will be different. Is that correct?
Yes.
Yes. So, but this will tell me about the chemical configuration, right? Now, how does that really, affect the chemical reactivity? See, every atom, every atom wants stability. Okay. And what is stability for atom? What is stability for an atom? Any idea, Jia? Mm-hmm. Where are you from, Jia?
Kerala.
I can't hear you better.
Hello?
Yes. Please be a bit louder.
I think it's the mic.
Yeah, now it's fine.
I'm from Kerala in
You're
India.
from yeah. Right now, where are you?
Huh?
Right now, where are you in Kerala?
No, no, I'm in Kuwait.
Okay, you're in Kuwait. Okay. So, what's the stability for an atom?
Being in a stable place.
How do you define stability for the atom? How do you define stability for us humans?
Like staying in one place for a
Is
long
staying
time.
in one place. Okay. So, you would be needing some financial success to be stable.
Yeah.
Yeah. So different factors will actually be, determine your stability. In case of in an atom, the stability of an atom is it's it wants to have the electronic shell as fully filled, as fully filled.
Fully
Okay.
filled.
And mind it wants to have the last electronic shell as fully. Do you understand this? We will discuss this in
Yeah.
detail. So how do I get to know the last electronic shell for the atom?
Uh, it has to be completely filled.
Yeah, but how do I know that what is your last shell? Is it second? Is it fourth? How do I know what is my last shell? Is it first or second or third? How do I get to know that?
You draw circles around it, and then
Sorry?
I don't know. There's like you draw circles on the shells,
Very
right?
good. So when do I stop? Should I stop at the second circle or should I stop at the third circle? Those
No,
circles are the orbits, right?
you draw the circles according to the atomic number.
Very good. Let's take the example now. Okay, let's take the example. So example is there's an atom with the atomic number that is Z is equal to 11. Can you tell me the number of protons here?
Uh, 11.
Number of electrons?
11.
11. All the protons will be in the same nucleus, so we are not concerned with that. Right?
Yeah.
We need to go on the electronic configuration. Can you tell me how many electrons in the first shell?
2.
Two. Do I need to move to the third shell?
Yes.
Yes. How many in the third shell?
8.
Eight. Do I really need to move to the third shell?
Yes. 1.
Yeah. One. Are the number of electrons complete here? Yes, they are.
Yes.
Now, this is the electronic configuration for this atom, which has atomic number as 11. Clear?
Yeah.
Now, can you tell me which is the last shell in this atom, for this atom?
1.
This is the third shell, right?
Yeah, third shell, sorry.
Third shell is the last shell. And see, I will use two phrases here, two very important terms here, that is the valence shell and the valence electrons.
Okay.
What is a valence shell, Gia?
No idea.
You have the idea.
The first shell?
The last shell, okay?
Oh.
So the last shell, people are not really concerned with the first shell. Our aim is
Oh.
to have the last shell fully filled, okay? So valence shell is nothing but the last shell. So in this case, clearly third shell is the last shell. Yes. Therefore,
Yeah.
third shell is the valence shell for this atom. Understood?
Yeah.
Yeah. Can you tell me what do we mean by valence electrons then?
It's balancing.
Electrons in the last shell, yes? In the
Yeah.
last or the valence shell. Can you tell me how many valence electrons do we have in this case, Bache?
1.
Very good. Fine. So that is valence electrons and valence shell. Now, what is the aim of the atom? What is the aim of the atom?
I didn't get you.
What's the aim of the atom? The aim of the atom is to have the
One. I don't know.
last shell as fully filled, yes?
Oh, yeah, yeah. fully
Yeah,
filled.
last shell as fully filled. Jia, can you tell me, looking at the electronic configuration for this atom, the third shell, which is the valence shell in this case, is that fully filled, Bacha?
No.
No. Is the second shell fully filled?
Yes.
Okay. So, what do I do here? To have the last shell as fully filled, I have two options here. Please be careful. I have two options here. Either I gain some electrons, in case 7 electrons, and I make the valence electrons in the third shell as 8. Then I will have that shell as fully filled. Agree?
Uh-huh.
I repeat. If I have 7 more electrons in the third shell, if I have 7 more electrons in the third shell, don't you think the total of electrons in the third shell will be 8 then?
Yes.
And that means if 8 electrons are present in the third shell, that means the third shell is fully filled. Yes or no?
Uh-huh.
Yes. The second option is that if I lose this one electron from the third shell,
You
if
can
I
lose the electron.
yeah, if I lose this one electron from the third shell, the third shell will become empty.
Yeah.
Then the last shell will become the second shell. That is, the second shell will become the last shell. Yes. And that
Yes.
is already fully filled. So in both
Yes.
the cases, we will get the last shell as fully filled. Do you agree with that, Gia?
Yeah.
Yeah. Therefore, what the atom will do is that it will decide what is more convenient for it to gain some number of electrons or to lose some number of electrons. Whatever is more convenient for the atom, it does that. Clear? In order to have the last shell as fully filled. See, we will see here what happens. But in simple words, if I tell you the stability of the atom, the aim of the atom is to have the electronic configuration similar to its nearest noble gas. Do you know what is noble gas?
Yeah.
Yeah, very good. So, if we have the noble gases, what is the atomic number for the noble gases? First is the helium with Z is equal to 2. Yes,
Uh,
yes.
Neon.
Then, very good. We have neon with Z is equal to 10.
Uh,
Argon,
10.
yes, Z is
Or
equal to 18. Okay, so at your
yeah.
level, that's fine. Now, see, we had, what do we had? What did we have right now? We had sodium, which is atomic number is 11,
11.
right? So 281. This is the electronic configuration, right? Now, what will be the
Yeah.
atomic configuration for neon? 2 and 8. Yes. Second shell
Yeah.
is fully filled. What will be the configuration for argon? 288,
8.
right? Very good. Now, which is more close to sodium? Neon or argon?
Uh, Neon.
Neon, right? The atomic number of neon is 10. The atomic number of sodium is 11. It's almost after neon, right?
Yeah.
Therefore, sodium will try to attain the electronic configuration as that of neon. And in order to do so, it will lose this one electron present in the third shell. Is it understood, Jia?
Yes.
This becomes the valency of the atom. The combining capacity of the atom, or in simple words, the number of atoms gained or lost to have the last shell as fully filled becomes the valency of the atom. Clear? I repeat. The combining capacity of the atom, the combining capacity of the atom, or in simple words, the number of electrons lost or gained in order to have the last shell as fully filled becomes the valency of the atom. Is it clear now? Yes.
Yes, ma'am.
I will give you one more example. So in this case, the valency of the sodium atom, which had 11 as the atomic number, becomes 1. Clear? Now see, look here. If its atomic number was 11, don't you think it will have a number of protons is equal to 11?
Yes.
Number of electrons also were 11.
Yeah.
Now what happens? Number of protons are 11. Number of electrons have been reduced to 10. Yes or no?
Yes.
So plus 11x and minus 10x, which charge becomes greater overall? Positive or
11.
negative? 11. Therefore,
Positive.
Therefore, it will gain a positive charge. Do you understand this, Jia?
Yes, ma'am.
So whenever the electrons are lost in an atom, it gains a positive charge. Clear?
Yeah.
Now we will have one more example very quickly. I'm telling you an atom, any atom which has atomic number as 8. Z is the atomic number. Can you quickly tell me the electronic configuration for this?
2 and 6.
2 and 6. Okay, so that's the electronic configuration. Is it fully filled?
No.
So don't you think it will want to avoid the electronic configuration as that of neon because it's very close to it? The atomic number of
Yeah.
neon is 10. Yes. So it wants to
2.
have this as 8, right? That is the
Yeah.
electronic configuration of neon. So what will it do? Don't you think it will gain 2 electrons?
Yes.
Yes, it will gain 2 electrons. Now earlier it had 8 protons, 8 electrons. Now it has 8 protons but 10 electrons. Yes.
Yeah.
How many? What's the positive charge? Plus 8p, but
Yeah.
minus 10e, right? Which overall becomes greater. Therefore,
Balance.
negatively charged. Yes. What's the valency here? How many
Um.
electrons does it gain?
2. Minus
2.
2.
Very good. Valency is equal to 2. Clear, Gia?
Clear, ma'am.
So, chemical change is nothing but a change in the chemical configuration of the atom. Chemical change
Uh,
is nothing but the chemical change in the chemical configuration of the atom, and this is what do we mean by the chemical configuration, right?
yeah.
And chemical reaction, what is it? It's nothing but the gaining or the losing of electrons.
Yeah.
How will this atom of oxygen gain 2 electrons? There must be some atom which would be losing some electrons, right?
Yeah.
So the two of them will actually react. The two of them will form a bond. Do you get it?
Yeah.
So this is the chemical reaction. I hope this is understood.
Yes,
Fine.
it's understood.
Now, the first 20 elements, let's say the first 20 elements are the most commonly used, okay, and that gives us the idea as to how our valency is there, okay. So I hope you have the first 20 elements with yourself,
Yeah.
yeah, and you are familiar with the valencies of all of them.
I think so. Yeah.
See, I will quickly write it down here, okay, so just pay attention. The first one is hydrogen. So the elements are arranged on the basis of the atomic number, right? So it's a serial
Yeah.
order, atomic number and the element. So the first element, which is hydrogen, obviously has the atomic number as 1, right?
1.
So
Yeah.
1. 1 electron, 1 proton. What will be the electronic configuration? 1 electron in the first shell. The second one
Yeah.
is helium. Z is equal to 2. That means 2 electrons in the second shell. This is an inert gas, mind it, noble gas, right? The third
But
one is lithium. Sorry.
isn't it valency 0? Helium.
Helium's valency is 0, but it is 0 because it has 2 electrons in the second shell.
Yeah.
Yeah, you getting it?
Yeah.
This is electronic configuration. So if I write valency here, it's plus 1, minus 1. Hydrogen might also lose 1 electron. Hydrogen might also gain 1 electron. If it gains 1 electron, it will attain this configuration. If it loses
Yeah.
1 electron, the shell will be empty and there will be no shell. Okay?
Yeah.
Understood, bache?
Understood, ma'am.
Right. So now, lithium, atomic number 3. Electronic configuration 1 and 2. What will be the valency here? Can you tell me? It wants to attain the electronic
1.
configuration of helium, right? So plus 1. It will lose 1 electron. This plus and negative here does not actually are with the valency. No. It simply means due to the valency, what is the change on the atom, right? So plus 1 means electron, the atom is losing 1 electron and because of that, it is gaining positive charge. Here? No.
Yeah.
Yeah. Fourth is beryllium. So Z is equal to 4. That means this was 1 and 2. Okay. So that means 2 and 2. Yes. It again wants
Yeah.
to gain the electronic configuration of helium, therefore plus 2.
Plus
Then
2.
we have, after that, we have boron.
Uh, Boron.
Z is equal to 5. So 2,
5.
3 plus 3.
1.
Okay. Carbon. Z is equal to 6, 2, 4. What will the valency here? It's generally
Uh.
minus 4. It gains 4 electrons. Okay. It
Yeah.
gains 4 electrons. Then we have oxygen. Z is equal to, sorry, not
Uh,
oxygen, nitrogen.
That
Then we have
means it's a
nitrogen.
set.
Yes. Z is equal to 7, 2, and 5.
A
Therefore, it
5.
gains 3 electrons, minus 3. Yes. Then we have
Yeah.
oxygen. Z is
Uh,
equal to 8, 2, 4, minus 2. Yes. Then we have
yeah.
fluorine.
Uh, 9.
Yeah, very good. 2,
2 and
7 gains 1 electron, minus 1. Then we
minus
have
1.
neon. See, neon
10.
has 10, so 2, 8, and 0. Therefore, carbon, nitrogen, oxygen, fluorine attain the electronic configuration as that of neon. Whereas
Yeah.
boron, beryllium, lithium attain the configuration as that of helium because they were close to helium. Do you get that, Bachcha?
Yes.
Fine, very good. Now, the 11th one is sodium. Yes, Z is equal to
Yeah.
11. 2, 8, 1. It will lose one electron to attain like that of neon.
Yeah.
Magnesium, 12. 2, 8, 2 plus 2. Then we have aluminium. Z is equal to 13. 2, 8, 3 plus 3. Then we have silicon, 14. 2, 8, 4 plus 4 minus 4. It actually is a metalloid, yes.
Yeah.
So then we have after silicon, what do we have, Vijay?
Phosphorus.
Phosphorus. Very good. After that, we have sulfur. Yes.
Sulfur. And then chlorine.
Phosphorus. Yes. So accordingly, you have it till argon. Okay. Till
Yeah.
argon, argon is 18. For
Yeah.
argon, what do we have? We have potassium at 19. Z is equal to 19. That means 2, 8, 8, and 1. Therefore, it wants to attain a configuration as that of argon. It will lose one electron. Therefore, the valency is plus 1. The atomic number with the element with 20 atomic number is calcium. Z is equal to 20. 2, 8, 8, 2 plus 2 as it wants to attain that of argon. Clear, bache?
Clear, ma'am.
So this is how atoms become two ions, right? Now, see
Yeah.
how, let's say we have calcium and we have oxygen. These are two separate atoms. Calcium wants to lose two electrons, oxygen wants to gain two electrons. Don't you think they can actually have a bond between them? Why? Calcium is giving two electrons, oxygen is taking those two electrons. Yes?
Yeah.
And what is the way? See, how many electrons can one calcium atom give? It's obviously plus 2 because that's the valency. How many electrons can one oxygen atom take? Plus 2. How do I get the chemical formula for these two? I will crisscross them and I will get the
Four.
formula as this. Do you get it, Bachcha?
Yeah.
Yeah. Now, see, we have three steps. If I ask you to calculate the chemical formula, you will have to follow three steps. First, write the symbols of the elements. In this case, we had Ca for calcium, O for oxygen. Then below that,
Yeah.
write the valencies, their respective valencies. In this case, we had plus 2 and minus 2, right? Then let's
Yeah.
crisscross it. Just crisscross. That's it. Now, I
Okay.
have one question for you, Gia. Please think and then answer. We have
Okay.
sodium and oxygen combining together. So how do I get
Okay.
the formula? I have plus 1 valency for sodium. I have minus
And,
2 for oxygen. I will have to
and
crisscross it. Yes.
yeah.
What formula
Na2
will I get here?
Na2O.
Na2O like this.
No. The two
Mhm.
will be
Subscript.
N. Yeah.
Very good. But one question. This is the formula that is very correct. What does
Uh,
this signify here? What is this telling us here? Why do we need to have two here? Can you tell me what does two tell here?
it basically gained electron. Uh, it basically gained from oxygen. Two
Mhm.
electrons from oxygen.
So, beta, in the earlier case also, we could have CO2O then.
Uh, yeah. But like
Yeah,
they get cancelled, right? The two.
yeah. So that is no electron giving is there.
Yeah.
Then how is the bond there?
Uh,
Next, let's take this aluminium and oxygen. Aluminium plus 3, oxygen minus 2. Crisscross. What formula do I get?
Al2O3.
What is this telling me? What does 2 and O tell me here?
The uh the atomic value.
Atomic value is what?
Uh, I don't know. The number of
Listen,
electrons.
listen. Very important. This is the fundamental to balancing of a chemical reaction. Please listen with full attention.
Okay.
Do you know one atom, right? If I write one O, that means it's one oxygen atom, correct?
Yeah.
Yeah, one O. I'm writing it here. Please pay attention. If I write
Okay.
just this, that means it's one aluminum atom.
Yeah.
Now what happens? Or if I write this is one oxygen atom. If I write this is one hydrogen atom. Gia, what happens if I write like this? What is this? Just focus
O
on this O2.
oxygen.
This is oxygen. Oxygen, right? So one
Yeah.
atom is it? Is it one atom?
Two.
Two atoms. So O2 means it has two atoms. But how many molecules is it?
Two.
Two molecules. What are molecules?
Uh, Wait. Mm,
See, single atom is there, like you know it, right? Whenever
yeah.
there is two or more than two atoms, we just need two or more than two atoms. Even if there are two atoms, it's a molecule. In simple words, group of atoms is a molecule.
Molecule.
If there are two atoms, we are not even concerned with three, four, five. Okay. Even if there are two atoms, that's a molecule. Do you get it? Even if there are
Yeah.
two atoms, that's a molecule. So molecule. Now molecule beta can be of two types, element and compound. Do you know the difference between elements and compounds?
Think so.
Say that.
Uh, Compound. I I don't know how to explain.
See, whenever two, let's say, same atoms, same atoms are combined together, that is also a molecule because two atoms are there, more than two atoms are there, but same kind of atoms, that means it's an element. If two atoms are there but different atoms are there, that means it's a compound. Example, O2. See, this clearly means there are two atoms, but same atoms of oxygen. Then it's a molecule, but the element. If I write H2O, clearly three atoms, but different atoms. Two of hydrogen, one of oxygen. Clearly it's a compound. Clear, bachche?
Clear.
But now you tell me if we have two atoms here, it's a molecule. My question is how many molecules of oxygen are here?
Two.
Two. And how many atoms are here?
Two.
Two. Then if atoms and molecules number is same, then what's the difference between them?
Um, the molecules are a group of atoms.
Yeah, molecules are group of atoms. So if I'm saying I have two molecules, that means I have two groups of atoms, right?
Yeah.
Yeah. And atom is what? Number of atoms. Tell me the number. If you are saying two atoms, that means we have two oxygen atoms in one molecule,
Yeah.
and then you are saying we have two groups of oxygen. Uh-huh. What is it?
Two group
See,
of atoms.
Ajay, tell me one thing. What is this?
Water. H2O.
H2. How many hydrogen atoms?
Two.
How many oxygen atoms?
One.
How many molecules of water?
Uh, Two.
How do you know that?
Because it's right beside H.
Mhm. But that is H, right? My question
Yeah.
was about molecule of water, not just about hydrogen atom. I already know the number of hydrogen atoms, that is two. Question
Uh,
says not hydrogen atom. Question says water. Then,
uh,
see, but pay attention. This is one molecule of water. This is one
one more.
molecule of water. Okay. And it has
Yeah.
two hydrogen atoms. How many atoms?
Two hydrogen atoms.
and it has one oxygen atom. You get it?
Yeah. Yeah.
But one molecule of water, because one molecule of water always, always, always will have two hydrogen atoms and one oxygen atom. Clear? No. Dear, respond.
Hello.
Yes, please respond. Is it clear?
Yes,
Yes. Are you writing or are you doing something else?
I was writing.
Okay. Good. Now, see, beta the number here. Okay. Let's say we have A, B. Okay. This
Okay.
one and this one. We have two different numbers written. Okay. This will tell me the number of molecules, the big number written before the compound name, okay, or the chemical formula, number of
Okay.
molecules. This number, any number in the subscript, and that will be for just one atom, particular atoms, right? That will tell
Yeah.
me the number of atoms.
Okay.
And if you are able to recall this, something related to atomicity. Okay. Now, if you have understood this part, I will come back to the water molecule. See, if I write this, it's one molecule of water, and one molecule of water will have two hydrogen atoms and one oxygen atom. Clear? What
Yeah.
happens if I write it like this? What does it tell you?
It has six molecules. No, six molecules of hydrogen and two number of atoms. Number
I could only hear till six molecules of hydrogen. What was the second part?
and two hydrogen atoms.
Molecules also, hydrogen atoms also, huh?
Or is
The
it
oxygen
12?
is left to nowhere, huh?
Or is it 12?
You need to give me one answer.
12.
12?
Yeah.
See, but when we are talking about a compound or a molecule, okay, this is one entity. This is one entity. I'm saying how many molecules of water. Now, water means this. It just does not. Water is this complete. All of this is water, right? Even if
Yeah.
hydrogen is not there, it's not water. Even if oxygen is not there, it's not water. You getting it, Bachchan? So if I'm
Yeah.
writing any number here, please pay attention. This will tell me the number of molecules of water. Getting it?
Yeah.
No. So this
Yeah.
means this is telling me six molecules of water. What is it?
Yeah. Six molecules of water.
Right. Now, if you are able to recall, this tells the number of atoms. And here
Yeah.
also 2 is same, right? That means in one molecule of water, two hydrogen atoms are there. In one
Yeah.
molecule of water, one oxygen atom is there. Therefore, in six molecules of water, how many hydrogen atoms will be there?
Uh, two. Wait.
Beta, what did you have today? For what time is there? You had your dinner?
No.
Hmm. I think you are hungry, huh?
No.
Are you a foodie?
Maybe. Is
Maybe.
it
Then I'm sure you are hungry. I think more of hungry.
so
Your answers are indication of that.
will it be 12?
You tell me what's your favorite food?
Uh,
Is that
pas-
also tough?
pasta?
Please be mindful of the fact that you are calling yourself almost a foodie, right?
Yeah.
Oh, that's why you're having confusion as to what food is your favorite. There are multiple favorite meals, dishes.
Yeah.
Okay, but you have to choose one. What will that be?
Uh,
A big sigh. Yeah.
wait, can you repeat the question?
The question says, what is your favorite dish?
Oh, I thought
What is your favorite? You
pasta,
have to choose one, huh?
pasta. I don't know.
Pasta? You're a Keralite, huh? Some good
Uh,
idli, dosa, sambar, something like that. No?
mm,
Oh, I thought you will tell me some good fish, some good idli, dosa, things like that, coconut chutney and something like that. You really told me one Italian dish that is pasta. No wonder your formulas are getting like this, huh? Interchange. No worries, that's fine. Just kidding. That's all of the fun side. You can have whatever you feel like as your favorite dish. But I hope you
mm,
like the idlis and the dosa.
uh, yeah.
Oh my god. Yeah, I think the answer is no.
No.
No, it's not no, or is it no?
No.
It's not. It's no. Fine. Yeah. Then your what's your second favorite one?
I don't know.
It's a pizza.
No.
No. You only eat pasta.
Uh, I don't know.
You don't know that also.
No.
Any scientist has to come and has to discover that.
Yeah.
Yeah. Fine. Let's study what the scientists have already discovered.
Okay.
Yeah. Beta, this is one molecule. Whenever we are referring to a molecule, we are talking this as whole. Any number beside this, like 8, that means 8 molecules of water. Clear?
Yeah.
Now, if I write 6 Al2O3, beta, this Al2O3 means aluminium oxide. If I'm
Yeah.
referring to the molecules of aluminium oxide, then this means we have 6 molecules of aluminium oxide. And one
Yeah.
molecule of aluminium oxide will have 2 atoms of aluminium and will have 3 atoms of oxygen. Is it clear?
Yeah.
Now, how do I calculate the number of each atom in the molecule? See, this number is for this atom, is for this atom. This number is only for this atom, and this number is only for this atom. To calculate the
Yeah.
total number of atoms, I will just multiply. For aluminium, 6 into 2. For oxygen, 6 into 3. In the similar
Yeah.
manner, but this is for hydrogen. This is also for oxygen because this number is referring to the whole of molecule. And this is all the molecules, right?
Yeah.
This
So it's
2 is
eight.
only for, and this is only for this. So
So it's
therefore, in case of 8 molecules of water, bache, in 8 molecules of water, how many hydrogen atoms do we have in total?
16.
Very good. 16 hydrogen atoms. How many oxygen atoms?
8.
8. Clear? Whenever there's no number written in this chemistry, that means it's 1. So if here no number is written, it means it's 1. Clear?
Yeah.
Now, see, next question. I'm giving you one question, you will solve it.
Okay.
Magnesium and oxygen react. Can you first tell me the formula, magnesium and oxygen? If they are reacting, what will be the chemical formula?
MgO.
NGO, the simplest one, answer. Okay.
Yeah.
Now, if this is the chemical formula, if how many molecules do we have for magnesium oxide right now?
1.
One. Very good. How many magnesium atoms do we have right now?
1.
How many oxygen atoms?
1.
Very good. If I write it like this, what will be the total information? How many molecules?
9 molecules of magnesium and 9 molecules of oxygen.
Repeat. 9 molecules of?
9 molecules of magnesium and 9 molecules of oxygen. Wait,
Repeat.
what?
You.
Can you hear?
Yes, I can hear, but that's the wrong answer. That's why I'm not answering, responding. Huh?
Uh,
9 molecules of magnesium oxide as a compound. And
yeah.
in those 9 molecules of magnesium oxide, I have 9 magnesium atoms and 9 oxygen atoms.
Oh, yes.
Get it? No.
Yeah.
Yeah.
I
Yeah. Yeah. So one question I'm giving you here right now. What is this?
It's to hide. Hide.
H2SO4, bache.
Wait. um,
Eating fish really helps with the eyesight.
Wait, I'm trying to remember. Wait.
Are you trying to
Um,
remember what number is this? LKG, huh?
no.
No, fine, no worries. See,
H2SO.
but it's H2SO4. Can you tell me, is it a compound? Yes, it is a compound. Yes.
Yeah,
What's the name for this compound?
H2SO4. Mm,
Yeah. Sulfuric acid.
yes, I get
Yeah.
confused. And
Between,
yeah,
you get confused between what?
sulfuric acid. There's another one.
HCl, hydrochloric acid.
No, I
Nitric
forgot.
acid, HNO3.
Yeah,
Fine. So this is H2SO4, that is sulfuric acid. But it clearly we have many atoms here. Clearly it's a molecule. Clearly different types of atoms. Therefore, clearly it's a compound. Are you able to understand this?
yeah.
Yeah. How many molecules of sulfuric acid do we have right now?
Molecules of sulfuric acid. One.
Very good. In that one molecule of sulfuric acid, can you tell me the number of atoms? Each atom, each element atoms. Hydrogen
Uh,
atoms, how many hydrogen atoms?
two.
Two. How many sulfur atoms?
One.
How many oxygen atoms?
Four.
Four. Very good. Now, if I say I have 8 H2SO4, what does this mean?
There's eight molecules of H2SO4.
H2?
SO4.
Very good. That means 8 molecules of sulfuric acid. Now, if I
Yeah.
ask you, can you tell me the number of atoms of each element in these 8 molecules of sulfuric acid?
Uh, H has 16.
Very good.
Uh, Sulfur has 8, and
Very good.
oxygen has 32.
Very good. So these are the different number of atoms present in the sulfuric acid. 8 molecules. I hope it is understood, Bacha.
Yes, ma'am.
Yeah. So now,
Yeah.
Bache, the number in the subscript, I repeat, the number in the subscript tells you about the number of atoms, and the number, the big number before the compound, the formula that tells you the number of molecules. Here. Now, I
Yeah.
will move back to my earlier question where we discussed what do we were calculating the formula for sodium oxide. We got +1 here, 2 here, we got Na2O, right?
Yeah.
What is this?
I need to
Compound?
sodium compound.
Compound, very good. How many atoms are there in this one? I'm sure one molecule, yes?
Yeah.
Yeah, how many atoms are in this one molecule, bache?
For Na, it's 2, and oxygen, it's 1.
In total, we have 3 atoms, right?
Yeah.
Yeah. Now, let's talk about this one molecule. What does it signify? Why do we have 2 sodium atoms and why do we have 1 oxygen atom?
Because we didn't change their.
You know, that's the answer. I was I wanted to listen. Good answer.
Is this correct?
I'm saying good answer, but I'm not saying it's the correct answer. I'm saying tell me some bad answer. Extremely ridiculous answer.
Uh,
See, but yeah, we say that oxygen, the valency of oxygen is -2. That means oxygen wants to gain 2 electrons. We are
yeah.
saying the valency of one sodium atom is +1. That means one sodium atom can give 1 electron. Correct? Let's
Uh-huh.
suppose if sodium and oxygen they are to bond with each other. So one oxygen atom requires 2 electrons. Let's denote like this. Okay.
Okay.
And one sodium atom is able to give just 1 electron. Correct?
Uh-huh.
Don't you think we need 2 sodium atoms to actually suffice for the valency of one oxygen atom? No.
Maybe.
But be a bit louder. I'm not able to hear you.
Yeah.
Yes. So we need 2 sodium atoms, okay, with valency of 1 each to suffice for the valency of one oxygen atom. Do you get it? Therefore,
Yeah.
this Na2O represents one molecule of Na2O has two sodium atoms and one oxygen atom, and this is what it means.
Okay.
Are you able to understand this?
Yeah.
If I say I have 8 molecules of sodium oxide, how many sodium atoms will I have in total? 8 molecules of sodium oxide?
8 molecules of sodium oxide. 16.
Very good. And how many oxygen atoms will I have in those 8 molecules of sodium oxide?
8.
That means for every one atom of oxygen, we have 2 sodium atoms. Is it understood?
Yeah.
Now, can you quickly tell me what does this mean?
Al2O3.
What is this?
And
A compound? A molecule?
a compound.
If it's a compound, it's a molecule. Yeah.
It's a compound.
Yeah, it's a compound. Very good. How many molecules of this compound do we have right now?
1.
One. In that one molecule of this compound, how many atoms are present? How many different types of atoms?
Uh, Aluminum, there's 2, and oxygen, there's 3. So there's a
Very
total
good.
of 5.
Yeah, 5 atoms and 2 different kinds of atoms, right?
Yeah.
Very good. Now, what does this signify?
What does it signify?
That means in one molecule of aluminum oxide, we
There is
require 2 aluminum atoms to bond with 3
oxygen.
atoms. Clear?
Yeah.
Very good. Gia, we have 3 minutes in the class. I'm stopping it till here. I want you to
Okay.
revise these concepts, and in the next class, we'll continue from this. Hopefully, we'll be able to finish